Question says, consider the following diagrams. Which was a positive delta S? And we have kind of a before and after. So delta S is change in entropy. Okay, S is entropy. And kind of the common way of thinking about entropy is randomness. More scientific or more technical way of thinking about it is energy dispersal in a system. So if energy is more dispersed after something has occurred, delta S is positive. If energy is less dispersed, delta S is negative, or if energy is more condensed. In this case, all we have is these, I presume, molecules in a system. And each of these molecules will carry some energy, okay? Whether these are molecules or just, I don't know, some kind of balls floating around. I don't know what they are, but let's assume they're molecules and we can see them. So they're big molecules. So anyway, we have these in a system. Each of these carries energy. And what happens in nature is that energy tends to become more dispersed. And the reason for that is because there's usually one ordered state and there are many, many, many disordered states. So if you think of like a house, for example, if you take a brand new house, right, and it's in perfect condition and everything goes well, and nobody buys that house and it just sits there. And let's say it sits there for 5 years. Is it going to be a perfect house in 5 years? No. What if it sits there for 10 or 20 years? Eventually the house is going to fall down. Why? Because there's one ordered, perfectly nice brand new house. And there are many, an infinite number of things that can go wrong with that, right? Moss could start to grow on the roof, or, the siding could fall down, or any of a million things that could happen to a house. But things don't tend to spontaneously go to an ordered state. They tend to spontaneously go to a disordered state. So basically what we're looking at here is energy dispersal in a system, and that's a long-winded way of trying to just answer this relatively simple question. So if we look at this case, this is the right answer. We have the energy condensed in an ordered state. It's all in the left-hand bulb, if you will. Then time goes on, and now it's kind of equally distributed between the two bulbs. This is what nature does. And here, entropy has increased. Nature increases entropy. So this is basically the right answer. If we look at this case, we have the disordered state to begin with, and it goes back to the ordered state. Usually, almost always, one would have to put energy in to get this to occur. All right, so someone would have to put energy in, just like somebody would have to put energy in to make that nice brand new house, right? A lot of energy would go into that to get those materials into that super ordered state. Here, it's just a weaker example of the previous. All right, so here it was more ordered to begin with, but it's still even more ordered at the end. So in both of these cases, entropy has decreased. So you could think of commonly entropy as randomness. If randomness increases, then entropy increases. But a better way of thinking about it is energy dispersal in a system. All right, if energy becomes more condensed, then entropy has decreased. If energy becomes more dispersed, then entropy has increased.